Okay, Assalamualaikum and good morning. Okay, could you hear me or not?
Can, sir.
Okay, thank you. All right, that is substitution cipher, right? And then we will continue with transposition cipher, right? In a transposition cipher, the letters or alphabet in plain text will not be replaced, but the position of that alphabet will be changed. Okay, the rule of the changes is the key. Okay, is the key. And this corresponds to Shannon principle of diffusion, right? And okay, transposition cipher cannot be done on stream cipher. It must apply block cipher because you need to have one whole block, okay, so that you can change the position of the plain text of the alphabets, right? The first one is a column noun. Okay, what we need to do is to create a row of matrix, a table, okay, like this one, okay, and then you just fill in your plain text alphabet A, T, T, A, C, K, and then fill all the reminding cell with X. This is not always. It depends on the crypto system. So you need to apply what being instruct on your question. It might be X, it might be Z, and so forth. So please, all right? And then you will apply, okay, you read, okay, vertically, ACX, TXX, TXX, A double X. Okay, you will have this. This is your cybertext. Okay, so what is the key? Okay, the key actually the size of the column, the number of the column 0, 1, 2, 3. Okay, remember, start counting from 0. 0, 1, 2, 3, 4. That is how you do your encryption, right? All right. Okay, now how we do the decryptions, we create the same table again. Okay, now we reverse, not start with row, but we will start with column. Column 0, 1, 2, 3. ACX, and then we write, okay, according to row. 1, 0, 1, and 2. Last, we need to remove all these extra characters. These extra characters can be called as padding characters or padding letters or padding alphabet. And it not always X. It can be any other letters. All right. Okay. Now, how we do cryptanalysis for columnar cipher, right? We need to figure out what is the size of the words. What is the size of the ciphertext? In this case, 1, 2, 3, 4, 12. 12 means 4 times 3 or 3 times 4. So the column size should be either 3 or 4. So we reconstruct back the matrix and write, okay, vertically and read horizontally and remove all the pending characters. Okay, I will show you in the lab next week. Right? Okay, so if the first try cannot come out with a meaningful word, means that the size of colon is wrong. So we move to the other possible colon size, which is 4. Okay, so it's quite straightforward. All right, but when it become bigger, right? For example, 45. Okay, we have 3 by 15, 15 by 3, 5 by 9, or 9 by 5. So the possible keys are 5, 3, 15, and 9. 3, 5, 9, and 15. So 4 possibility, right? And these are the possible transformation. 242. Right? So what is the possibility? Okay, what this science called uh, okay, I can't recall the term for this symbol in math. Okay, but we have about what? 2, 4, 3 times 2 for 2 times 2 for 1 times 2 for 1 and time 1. So that is the possible transformation. Right? So now is quite secure. So it means that the bigger the block size means is more secure. Sorry, okay, someone try to join in. Okay. All right. Okay. Next one. Double transposition. Here means, okay, the first transposition, we do it on the plain text here. And second transposition, we doing at the key. Right? Okay. So now we have this. When we apply second transposition, so it have many more possible combination. Okay, many or more possible combination. Instead of 4, 2, 4, 3, okay, we have 2, 4, 3 in this example times 4 times 3 times 2 times 1. Okay, we have more, okay, combination. It make more secure. Okay, now the second transposition cipher, rail fence. Right? Okay, now what we will do actually, we will create the table like this one. Okay, and then we write zigzag. The size of the, sorry, the number of the row is the key. Okay, in this example, the key is 3. 1, 2, 3. 0, row number 0, row number 1, row number 2. And then we write zigzag. Okay, and then we write row by row. Okay, how to decrypt it? Okay, right? We create the same table again, right? And then we write letter number 1, number 2, number 3, number 4, number 5, and then we write, okay, row by row and read zigzag. Okay, so we will get attack. Okay, that is how we do decryption. Okay, if you compare this with the columnar, it doesn't have padding characters. All right. So what is principle? Shannon's to principle. Okay, we have learned two, confusion and diffusion. If your FYP related to cryptography, you need to discuss your algo from this angle. Confusions and diffusion, because this is the key properties in any crypto algo. Right? So confusion, okay, they are to obscure the statistical dependence between encryption key and cybertext. Okay, in a layman word, we try to diffuse, okay, all the relationship between key and cybertext. That's all. So now if we change key one character, it can influence a lot in up to cyber attacks. Okay, diffusion. Okay, now we try to de-associate plain text from cyber text. Okay, to obscure the statistical structure of the plain text from the cyber text. The first one, we try to de-associate key and cybertext. The second one, we try to de-associate plain text with uh, cybertext. Okay, by applying these two algo, sorry, by applying these two principles in our crypto algo, it will create avalanche effect. What is avalanche effect? Avalanche, avalanche, avalanche effect. Okay, when we change one bit, it will create a ripple effect that will transform large portion of the cybertext. Okay, so what we have concluded, okay, we can categorize a cryptography based on a processing method: string cipher and block cipher. String cipher means we will transform one alphabet at a time. Okay, the second one is block cipher, where we need to change a few alphabet at a time. Okay, because of this, okay, transposition cipher can be done only with block cipher. Transposition cipher cannot be conducted on string because we have only one alphabet, one letters, one character. We cannot change position of that particular letter. Okay, while substitution cipher can be applied both string cipher and block cipher. Okay, now in substitution, we have two subcategories, which is monoalphabetic and polyalphabetic. Monoalphabetic means we apply one single substitution rule for every alphabet. Okay, why? Polyalphabetic cipher, substitution cipher, we apply two or more substitution rules, okay, in for every alphabet. Okay, if we have two, we still call it polyalphabetic. If we have 3, 4, or 5, we still use polyalphabetic. Okay, and how we apply the key. Okay, we will learn this a bit more next week. Okay, we have to symmetric mean we use two different keys. We call it private and public keys. Okay, on symmetric cryptography, we use only one single key. All right, so that is classifications of cryptography. Okay, crypto algo. Okay, requirement, security requirement. Okay, cryptography can handle confidentiality component of computer security. We can apply symmetric cryptography or asymmetric cryptography. Then to comply for integrity component of computer security. Okay, we use hash function. Hash function, also known as one-way cryptography, where we can do encryption, we cannot do decryption. Okay, we will cover this also next week. Right? Next, authentications and non-repudiation requirement. Okay, this where we can apply digital signature, okay, which based on asymmetric cryptography. This we will cover also next week. Right? Okay. And if you have any question, you can ask me in Telegram. Okay, we will stop now. Okay, I will show you how to do all these crypto algo. Okay, shift cipher, two-digit substitution cipher, reverse frequency cipher, Virginia tableau cipher. Okay, one-time pad, columnar, and real fan during lab next week. All right. And for group A and B, we will have online tutorial or lab tomorrow. Okay, if you have any question, you can ask me in Telegram. Right? Okay, until next week. Thank you.
Thank you, sir.
Thank
Thank you,
you.
sir.
Thank you, sir.
User.
Thank you,
Thank
sir.
you, sir.
Thank
Thank you,
you.
sir.
Thank you, sir.
Yeah.
Thank
Assalamualaikum
you,
ya.
sir.
Sir.
Right. How to pull up.